So in the last session, we have discussed about XPath locator in Selenium, right? So how to find or locate elements on a web page using XPath. So when you are not able to find elements on the web page using the basic locators, then we can use XPath. And it's always a good practice to use XPath, which actually gives you the unique address of the element. So using XPath, it's always possible to have get the unique ID of the or unique, we can identify the element uniquely on the web page, right? So that's what we discussed, and we have discussed different XPath functions, right? So in today's session, we'll discuss about XPath Axes. So in some cases, even like using relay to XPath might not be sufficient, or it's not possible. So you'll get some XPath, but that might not be, uh, sufficient enough to uniquely identify the element on the web page. In such cases, we do use something called XPath Axes. XPath Axes. So what are XPath Axes? So XPath Axes is used to navigate the elements and nodes in the HTML or XML document from the current context node. So that's very important. From the current context node, we navigate through the elements. Till now, like if we take relay to XPath, we actually navigate from the root node. And for the relay to node, we directly jump onto the attribute. But XPath Axes, we actually navigate through the elements from the current context node. So we locate the nodes related to the current node in the document. So based on the relationship with the other elements, we actually identify the nodes. So that's what XPath Axis does. So what is the syntax of it? So XPath Axis, what it does is, based on the current node context, it will identify the other nodes with the relationship it has with the other elements. So sometimes, say for example, you might be having some elements, right? Like this. And in order to identify it, say for example, this is my current node. So I wanted to identify this node. Say for example, this node in the web element, in the web page. So this is a web element, but it doesn't have, I am not able to locate it using any of the known locators. So say for example, it might not have any attributes, or it might, we might not be able to uniquely identify it, right? So in such case, what we can do is we can take some current node. Say for example, say this is current node. Using this current node, we can access this element which we wanted to locate. So that's the whole concept of XPath Axis. So this node, which we use it to identify the other element, so this is called as current node or context node, or we can say current context node. All are same. So this we call it as current node. And the element which we wanted to find is the desired element, which we wanted to locate. So this is about the XPath Axis. So this is the high level definition. Now we will see the syntax. So what is the syntax? How do we use the XPath syntax? So first we will have the relay to XPath of known element or current node. Relay to XPath of current node. We will come to see like what do I mean by current node? Current node and then axis. Axis is, we do have different XPath axes. So we do have multiple, XPath axes, like self is the same or same node. The current, it actually represents the current node, and so on. We'll come to that. So before that, so this is the syntax. We will write the relay to XPath. We'll have the relay to XPath of the current node. Then, so you can see I started with 2 forward slashes. So which means that it's a relay to XPath of the current node, and then 2 forward slashes again. Then axis in the sense one of these XPath axis, followed by a tag of the desired element. Axis will be the one of this XPath axis, which actually represents the relationship of with the current node. So this is the syntax. Now let's try to understand all of this XPath axis with an example. So here you can see a hierarchy of elements, right? So this is in a tree structure. So just we'll first try to understand this, and we'll try to apply this to the web page, because like even in web page, web elements are in a tree structure, right? So the objects are in a tree structure. So this is an example which actually represents a tree structure, right? So first let's try to understand this. Now, if you observe, so this is a hierarchy. This is also in a tree structure, right? So if you observe, I'm directly selecting this mammal here, right? So if you see this mammal, right? So this is our context node. So our current node, it is called a self node even, right? So from this, I wanted to find out the other nodes or elements which have relationship with this context node, because we might not be able to identify these elements uniquely with the existing locators, already existing locators. Say, for example, I wanted to locate this vertebrate with mammal, right? So vertebrate, how it is connected? It is directly connected as a parent. So mammal is, you can see, is just below the vertebrate, which means that mammal is a child node of vertebrate. We can clearly see that. And vertebrate has two childs, two children, fish and mammal, right? Mammal has one parent, you can see here, vertebrate, right? So with this context node or mammal, we can actually identify the parent. When we say parent, right? So this vertebrate can be selected. So with mammal, we will have the relative XPath written for mammal, as we do know the XPath for this mammal. XPath exists for this context node. So first we'll write the relative XPath of this current node, and then followed by the parent. Parent will be the axis, because we wanted to identify this element vertebrate because it doesn't have any attributes which are helpful to locate it uniquely on the web page. So we are taking the help of this one node, any node, which we call it as current node or context node. Using this context node, we can actually locate this element called vertebrate, which is a parent in this case, right? Parent, and then a corresponding tag of that parent. So that's how we locate this element called vertebrate, which is a parent of mammal. So if this is understood, so rest of them are all same. We just need to learn the terminology, right? So this nomenclature and what's the how the relationship is, right? So mammal here. So using this current node, we were able to identify the parent of it, right? Vertebrate. So in the same way, right? Mammal do have its own children, right? Herbivorous and carnivorous, right? So we wanted to find child with respect to mammal. Carnivore is a child to mammal, and we wanted to locate carnivore using mammal. So in that case, what we do, we provide the relative XPath of mammal, and then we provide the access child. I wanted to access child is what we'll say, and then two colons, then a tag with respect to the child, which child we wanted to select or locate on the web page. That's what we provide. So using this context node as mammal, we are going to identify this carnivore. This might be maybe like carnivore, we might not be able to identify it uniquely. So we'll take the help of mammal, which is a context node, which might be located uniquely, and using, like, say for example, something like relative XPath, then using that context node and using that relative XPath, we will be able to locate this element which is a child of mammal. So it is at a just one step below the mammal, right? So parent is one step above the context node, right? Now, this is about the child. So that is the child relationship. And parent relationship is just one step above, one level above the context node. Child is one level just down the context node, right? So, or self node, we can even call it as self node. Then, how about this relationship? So, mammal is a child of vertebrate. Vertebrate is a child of animal, if you see. So, this context node has some indirect relationship with this animal, which is a parent of parent. So, we call this as ancestor. So, when we call ancestor, so all are ancestors. Above, which are all like mammal, these are all, we can call it as ancestors. So, but if you see, the ancestor will be like what if it has to be parent of parent. Parent and also parent of parent are all called as ancestor. So when we say, when using this context node, we can identify this hierarchy, which is like parent of parent. And again, the animal might also be coming from some other node. So if there is any other node, even that will be called as ancestor, and even that can be identified. So all that we need to do is, so provide the relative XPath of this context node, followed by the keyword called ancestor, and then a corresponding tag of that node which we wanted to locate. So that's what ancestor is. Parent and parent of parents are all ancestors for the context node. Now, descendant. What is descendant? It is exactly the opposite of it. So child of child, child and child of child are all descendants of the context node. So in this case, mammal, so carnivore and lion and tiger, both are the descendants. So child, lion, tiger, all these are the descendants of context node mammal. So using this mammal, we'll write the relative XPath for this, and then we will actually use the keyword called XPath Axes keyword called child, and we can able to identify these elements, descendants, all the descendants. Even this hierarchy might go to any other level, but still we will be able to identify this descendants using the XPath of mammal. Only thing required is it has to have the relationship. So mammal, right? So it has a relationship with its child, and child has again child, right? So using this relationship, we can actually identify we'll locate the element on the web page. So only thing required is we need to know the relative XPath of the context node. So, or indirectly we can say we are going to select the current node or context node as the one which will have the known XPath. So we'll select such node, and using that with the relationship of that with other nodes, we'll actually find the these elements, which are like descendants in this case, right? So related XPath of the current node, then XPath axis descendant here. When we say descendant, all these nodes are eligible for selection, and within that we uniquely identify it. We have two colons, and then we'll specify the tag of this child or the descendant which we wanted to select. So that is about the descendant. So descendants are all like which has a relationship with child as well as its children again, right? All the levels of the childs are all descendants. And how about the siblings? So if you observe, mammal has same, so at the same level, it has some nodes. See, fish is at the same level, and other is also at the same level. So just for alignment purpose, it was written here, but you should be considering this other is also as a child, right? So fish and other are the siblings of mammal, right? So how do we actually represent this? So we can easily say that one parent, so all the childs of one parent, right? So they're all called as siblings, fish, mammal, and other in this case, right? So for mammal, fish, and others becomes siblings. So using this relationship, we can identify these elements as well. So what we need to do? So whichever comes before this node, current node, we call them as preceding sibling. So just above this node, current node, whatever comes, those we call it as preceding sibling. It has to be at the same level. It has to be at the same level. So in that case, we call them as sibling, and it has to be at the same level in the sense both the node and the node which we wanted to find, both should have the same parent. We can even understand like that, right? So using the current node, we can identify the sibling nodes. So how do we identify? If it is coming before the current node, then we say that it's a preceding sibling. The keyword is also same, the access keyword. We will use this same as is preceding sibling, right? So preceding sibling will be the immediate sibling, which has the same parent as the context node. So next will be the following sibling. Following sibling is the sibling or the node which comes just after which has to be the same level, first of all, which has to be at the same level of the self node, and which comes after the context node in the web page is called as a following sibling. Is called as following sibling. And we do have two more axes. Those are called as following and preceding, right? So we'll go through that. So these are the main XPath axes. So it's very simple. So when we wanted to identify the nodes, right? Nodes represent nodes in the sense you should be considering them as elements here. On the web page, we have the elements, right? So they are there in a tree structure as objects, right? So using the context node or the current node, we can, and with the relationship of other nodes with this, we can identify the other elements as well. So this we do only when we are not able to uniquely identify the other elements. Then we take the help of the XPath of relative XPath of the current node, and then we can identify the other elements with the relationship it has. So parent will be the just one node above the current node, and child will be one node just below the current node. And ancestors are all parent and its subsequent parents are all called as ancestors for the current node. And child and its subsequent children are all called as descendants. And if there are any elements which are at the same level, then they are called as siblings. And in order to identify them, so whichever comes before the current node, we call them as preceding siblings. And whichever comes after the current node, those are called as following siblings. So this is all about the XPath axis. Is that clear? If it is clear, we can see examples. All right. So now let me show you examples. So self is the current node. In order to select the current node, we can use this axis, self. Next, parent. So when we use parent, it selects the parent of the current node. It selects the parent of the current node. So example can be like this. So example is, say for example, child is your current node. Element with child is your current node. Then what we can do? We can use this ID of child, so which represents the relative XPath of the child, which we are able to uniquely identify it on the web page, right? So now we have the XPath of this. Using this, we should be able to locate the parent of it, because we wanted to locate the parent itself, but as parent might not have the XPath attributes or no other locator which we can use to uniquely identify it. So we can use the current node or the context node, and using that we are trying to find the parent of it, right? So this is how you need to write, and the parent tag is div. So the parent the tag of the parent is div. So we need to mention that as well. See, access is parent, tag is div. So this is the related XPath of the context node, which actually matches with the syntax, right? So now let me show you the example. So how do we locate a parent element? So if you see here, known XPath, and then this is the syntax, parent. So this you need to observe. So 2 colons. This is important. 2 colons, and then a star. Star represents all the parents of this element, which has a known XPath or current context node, self node, right? Or you can directly specify the element itself, element name itself, that is tag name. You can identify the tag name. Or if it has if it has more than one match with the tag name, then we will identify it with the index, or we'll use some other attribute. So if you see, XPath of the known element here is text username, right? So whatever is highlighted here in green is the current context node. Using this, we can find the parent of it. So how do we do that? So if you see, input name equal to text username, ID equal to text username here, right? So using this, what we can do is, so using this, we can write the XPath for this, right? So XPath for this known one, which we can call it as a current node, right? So input ID equal to text username. So this is how we write the relative XPath, which we have learned in the last session, right? So this actually identifies the current node. Fine. Then a single slash, because we are not actually trying to have the relative XPath, but we just wanted to go with one level, right? So then we say that slash parent. So it is just parent. What is the parent? So if you see here, we can, if we collapse this will be the parent. Form will be the parent, right? So colon form, which actually identifies the form in this case. And we can even replace this tag with star as well. So if it has only one parent, that will be selected. Or you can see the other syntax as well. So slash, and then you can even use dot, which also represents the parent, element. So this is how we can identify the parent using the current node. So when we say parent, it will actually identify its immediate parent, like from which it is derived, right? So in this case, div, and within div, there is an input name. So input name, then it will directly identify the form as a parent, right? So you can see here, correct, right? So within div itself, we have input. So it will consider form as a parent. And this is how we can write the XPath for it. We need to identify this form tag here, which is a parent of username. No. So there can be only one parent to a context element, and specifying the element name is optional here. So if it has only one parent, then we specifying the name is optional. Anyway, even star actually represents that element. So, but it is good to specify the element name for readability. So which tag you are actually specifying. So it is always better you specify the tag name here or the element, right? So this is about the parent. So how do we locate the child element? Take this as an example. So whatever is highlighted, again, username. So we consider this as the, okay, we are considering username, div ID equal to username, class equal to text input container. So this we consider it as the current node. Using this node, we wanted to identify the child elements. So you can clearly see that input and span here. These are two tags which are at the same level for the div ID or div username, right? So both are at the same level. So this becomes div for div, these two becomes div tag, these two tags, input and span, becomes the children. So in this case, how do we can identify the, write the XPath access? So first we will try to write the related XPath of the current node. Current node here we selected as div username. So div username is the relative XPath. Fine. So this became the our current node. Then slash child. So when we say child, so both input and span are eligible for selection. So colon both input and span are the possible children, then we have to specify which child we wanted to select. So I wanted to select a tag child with the tag input is what we are specifying here. In case we wanted to select the span child, we'll just specify the tag as span here, so that the child which is has the tag as span will be selected for the div username. So So in reality, for this example, we don't even need the child, right? So you can directly actually specify it with the input itself, right? But in case if you do not have that, right? So if you wanted to have the XPath access, right? So this is how you need to find out the relationship. So as this has a relationship, so you can use the XPath access like this. So div username and its child. Child are two nodes, input and span. So we can specify the tag here, which child you wanted to select. So this is about selecting the child. So when you specify child, it actually selects all the children of the current node. So when we say child, selects all children of the current node. So how we specify then? How do we identify? So we select parent and we call that as a context node. And this can be either single slash or double slash. So double slash represents the relative path. Single slash represents the, absolute path, immediate nodes. So this is about the child. So locating the child element using the parent element as a current node. Now we will see locating ancestors of the known element. So how do we identify the ancestors of the current node? So what did we learn? Like what did we understand about ancestor? So ancestors are the parent and parent of parent. Again, parent of parent, like that. Say for example, I do have something called my self node, or this is current node, right? So it might be having some one parent node, right? So again, this will be coming from some other parent. This can come from some other parent, like this. Go on, right? So all these becomes ancestors of the current node, even including the parent node as well. So all this becomes ancestors. So we can use the ancestor keyword here, right? So if you come to this example, so here input name, text user name, right? So this we are calling it as context node. Input name equal to text user name becomes the context node. Using this, we wanted to find the ancestors of it. So ancestor, and then you can specify the tag of the ancestor, because once you write slash ancestor, all the parent nodes of this node, right? So parent node of this is div username. Uh, no, it is form, right? Directly form, and then you can identify. Say for example, if you do have some other elements for the form, right? So form might be derived from some other element, right? So that becomes the ancestor, and the whole hierarchy, right? So all the hierarchy, so that becomes, all those becomes the ancestors. So in that case, we need to uniquely identify which ancestor we are referring to. So then we'll use the tag for it to uniquely identify which ancestor we are referring to. So we'll select the form element in this case. And if you do star, right, so then what happens? Div element will be selected from the available candidates, because it comes in the first in the path, right? So it comes in the first. If you use the find element, so only div username will be, find element actually returns one element. We know, right? So find element is a method which actually even though if you have multiple elements, select which actually matches with this XPath or locator, whatever you're using within the find path method as a parameter, then what happens? So if multiple elements are matched, then it will actually take the first element which is matched, right? So in the same way, if you specify ancestor and do this star, right? So so all the ancestors which are eligible will be selected, right? From that, the first one will be selected as the ancestor. So ancestor is simple. So the parent and the corresponding parents as well. Parent of parent, like that. That hierarchy, all those will be called as ancestors. So using the current context node, we can identify these ancestors like this. The ancestor selects all ancestors, parent, grandparent, and so on, right? For the current node, we specify the child node and then its corresponding ancestor and an ancestor tag to uniquely identify the ancestor if it has more than one ancestor. So that is about the ancestor. Now, coming to descendants. Descendants are all the child and grandchild and so on, right? Child, again its child, like that, and so on. This is self node. This will be the child. And say, for example, this is child of child. C2 is child of child. So all this we consider as descendants of the current context node or self node. All these are called as child nodes. Sorry, descendants. This will be the child node, and all the others are called as descendants of self node, right? So if you see here, how do you locate the descendants of the known element? So here the known element is form login, right? So form login is considered as form, right? Form is a tag which we select as a current context node, and you can see / form id equal to form login, which actually represents the current node. Then / when we say descendant, all the elements which comes below, we can say not the all the elements, but the child, first child, and the child of child, like this, right? So it has to have this relationship. So child and its immediate child again, like that. So its grandchild and so on. So it has to have this hierarchy. In that case, all of these are called as descendants, and we can identify using the axis called descendant. So / descendant, and all the elements child, grandchild will become the possible elements to be located. Then we specify this colon and a tag. We wanted to specify which descendant we are referring to. So we will specify the corresponding tag. So this is how we actually select the descendant of the current context node. So descendant is child, children, and the grandchildren of the current node. So we use descendant. To actually select the children. All the descendants we select. So descendants are children and grandchildren and so on, right? Of the current node. So the syntax is we need to have the relative XPath of the parent, and then / descendant is the keyword of the XPath axis, then colon tag of the descendant which we are referring to. To uniquely identify the descendant, we need to specify its tag here. So this is about the descendant. No, locating the following elements. So how do we locate the following elements? So following elements are, so if you observe here, so let's take E is representing the current context node here. If you see, username is text username, txt username. So we can either use name or ID to write the XPath of it. So ID has been used here. So input ID equal to text username is a relative XPath which identifies this current node. Using this node, we can specify a XPath access called following. When we say / following, all the following nodes. So all the following nodes, so will be selected. Will be selected as the candidates for selection. Selecting the uniquely identifying the element, right? So following, and then we need to specify the tag in order to uniquely identify that particular element which we are referring to. So what's the difference between the earlier one, when we select descendants and this one. So you can see keyword can be used for locating anywhere below the tree with respect to a known element. So it can be anywhere. So it need not have this relationship, but it can be anywhere below this. Meaning, say for example, this parent might be having, okay, let me give you that example. So this parent might be having some other node, which is its sibling of S1, right? So say for example, I do have some other child here. Say for example, some S2. This again might have some S3 like this, right? So this S has relationship with this S1. So it can identify this, but it can't go with this S2, S3, and so on, right? So say for example, this can have some S4. But still, all these elements can be identified using following. Whereas children, it has to have a direct relationship first with the child, and then it can have the other relationship, right? So you can identify the child and from their grandchildren and so on. So then that becomes a descendant, right? But following could be not only child and grandchild, right? It could be anything from anywhere. It could be anywhere. So this S2 has no relationship with this S, right? So it is completely different path. But still, all this anywhere it could be like say for example, it might be coming from directly from this parent as well. See, it has no direct relationship, right? But still, all these, say for example, maybe this is not the right example, but if you see all the nodes which are below this level, say for example, this parent might have some other node which is at the same level, and it might have its own element, right? So all those elements can be selected as using a keyword called following. Using the keyword called following, all the elements can be. So you can simply say that all the elements which comes under this current node, right? All the below elements, all are eligible for this following, right? So when we say following, all the elements under this level of the current node can be selected. That's the reason it says is used to locate elements anywhere below the tree with respect to the known element, the context element, right? So if you see here, username has been used, then slash following, and then see input, all these are following candidates, right? So following elements. So we have to specify the tag for it, which we are referring to input. So when we say input again, so here there are two inputs. So in order to uniquely identify it, so if you see here, there are two candidate elements, right? Any descendant elements after the first candidate in the path are excluded by Selenium when you use find element. Yeah, we know this. Find element can only identify one element, right? To select the login button, say for example, text username has two elements which are below its level, right? Text password and submit or login button. So we wanted to say, for example, select login button within these two using following access path, right? So when we use this access following, and when we say input, there are two elements to be selected. So in order to uniquely identify it, we have to specify one of its properties. So we say when we say 2, right? So it will be selected as 2, like the button, login button. So we have two tags, but I wanted to select the second input is what we are specifying here. So input last is it has to have some attribute. So this is not there here, but it has been used. So you can just ignore this first one. We can just say input of 1 to represent the password here, input of 2 to represent the login button here, right? So that's how we can use the following. See, to keep it simple, all the elements which comes under the current node can be considered as the following nodes or the following elements. So select everything in the document after the closing tag of the current node, right? So the current node and then slash followed by following. So following selects everything in the document after this tag, after the current node tag, right? Now, in the same way, just reverse of it, preceding element. So the preceding element is used for locating an element before the known XPath element. That is, before the context node, whatever comes, right? So not only the parent, so it can be at the any level. So it should be at the above the current node, but it can be coming from any other path, not only from the parent. So all those which comes before the child node are all located using the preceding XPath access, right? So how do we identify XPath of the context element? So here is an example, right? So span here is the context node. So span, then we can use text function here, XPath function. If you remember, we have learned this in the last session. Text actually retrieves the inner text of the element, right? So here the inner text is password, if you observe. So that will put it in a single quotes, which actually identify which will be the related XPath of this password, right? Now slash preceding. So when we say preceding, all the elements which comes before this current node will be eligible for selection. Then colon, the tag name, input, right? Again, when we say input, there will be two candidates for selection. We have to specify which input we wanted to, or which element we wanted to select. So here it said like input 2, right? Input of 2. You can see here, input of 2, meaning, so here we should count it as this as 1. So we are going, how we are actually traversing, that's how you need to calculate the levels. So this will be input 1, this will be input 2, right? So in this case, username will be selected. That's what our above can be used for selecting the username field. So if you wanted to select the password, right, for this span, then you will be specifying the input of 1. Then it will select the password here. So this is how you can use the preceding access to actually select the elements which are above the level of current node. So when we say preceding, it selects all nodes that appear before the current node in the document. So how do we do that? Relate XPath of the current node slash preceding is the access, and then colon the tag of the element which we wanted to select. So that becomes the preceding. So that's all about the preceding. How to select the nodes which appear before the current node using the preceding access. Now, coming to following sibling. So what is following sibling and what's the difference between following and following sibling? So following sibling is at the same level. So following actually selects all the elements before the current node. But when we say following sibling can be, following sibling is all the nodes which comes after the current context node. That is all the child nodes and all, right? So all nodes can be called as following nodes. But when we say following sibling is, it has to be at the same level of the current node and it has to come after the current node. That's what we call it as following sibling, right? You can see here in this example. So username here is selected as the current node. And using that, when we say following sibling, it is span is at the same level, right? So span can be considered as its following sibling. As only if it has only one sibling, then we can even use the star here to select it uniquely, right? So following sibling span can be used to uniquely you can use the star, which represents its following sibling. So how we can understand this is simple. It has to be at the same level. See, input and span are at the same level, right? So in order to identify it, we can use the following sibling. Why we are using following sibling? Because span comes after the current node. That's the reason we are using following sibling. And if it has more than one sibling at the same level, so to uniquely identify, you need to provide the tag name of it as well. So this is all about the following sibling. So what's the difference between following sibling and the following? So following actually selects all the nodes which comes before the, after the current node, right? But following sibling is at the same level. It will only select the node which is at the same level as that of the current node. That's the difference between following and following sibling. So following sibling actually selects all siblings of the after the current node. After the current node, right? So which comes, so in our case, like when we talk about the web page elements, all the elements in the sense, all are which are below the current node are called as following sibling. All in the sense like at the same level. Following sibling is selecting all siblings after the current node. So in this case, maybe S2, all are which are to the right side of the self node can be considered as following sibling. And preceding sibling is exactly the reverse of it. So it is used to select the siblings that comes before the context node or the current node, right? Which it has to be at the same level, first of all, and it has to come just before the current node. So it has to come before the current node and it has to be at the same level. For example, in this case, again, username has been selected as the, you can see username here, right? So context. So here it a different function has been used, right? Contains text. So contains actually we can specify the substring of the substring, right? So contains text. Text actually gives you the inner text. Inner text is username here. So it has to have, it has to actually match with this parameter, second parameter of the contains. Yes, it matches, right? It is exact match actually. You can even specify a substring of that as well. It matches. So yes, taking this as a relative XPath, username as a known XPath, relative XPath. Then slash preceding sibling. Preceding sibling is which is at the same level as that of the current node, but which comes before the current node. So that's the condition of the preceding sibling. Then what's the difference between preceding and preceding sibling? So when we say only preceding, all the nodes which comes before the current node, all the nodes, irrespective of this their relationship, right? So all the nodes which are above the current node will be selected as preceding nodes. But when we say preceding sibling, so it has to be at the same level. See, input and span are at the same level, right? So when we select span, then we can actually say preceding sibling to actually locate the input because it is coming just before the span, but it is at the same level. That's what we need to observe here, right? So preceding sibling is just comes above the span. So span is the current node here. So we just need to specify the tag of it. Or if it has only one sibling, preceding sibling, you can just replace it with star. So that is about the preceding sibling. And when we say preceding, all the nodes which comes before the current node will be selected. That's the difference. Preceding sibling will select before the elements, but it has to be at the same level as that of the current node. So selects all siblings before the current node, right? So when we provide the relative XPath of the current node followed by preceding sibling, which actually selects the just sibling of the current node just before the current node. And we have to specify the tag. So this is about the preceding sibling. Any questions? Is that clear? Any questions? Hope it is clear. So these are the important XPath axes which can be used to identify the elements with the relationship with respect to the relationship of the current node, right? So we do have other ones. So you can see here. So with this, you can see we do have some other access as well, like attribute, ancestor or self, descendant or self, namespace and self access. So they do not have practical usage in the context of Selenium, so we are not discussing them. Or else these are also called as comes under XPath Axes. So we are not discussing them as they do not have practical usage in the context of Selenium. Right? So this is all about XPath Axes. And we can even use some condition. In the condition based we can use. So in some cases, we wanted to identify elements based on some condition. So how do we do that? So in the last session, we had discussed about something called text. Text is a function, XPath function, which can actually retrieve the inner text of the element. So inner text of the element, right? So when we say for example, in this context, right? So whatever has been highlighted here in yellow. So if you see here, the inner text of it is 124.00, right? So that's a decimal value, and you can see that's the price of this item. How do we retrieve it? We can actually do this span of text, right? So when we do / span of text, then we get the value inner text, that is 124. Say for example, that value might change if there are any off words, or say for example, if I wanted to select another span. So I just wanted to select another span, right? So in that case, the text might be actually different. So it might be having a different price. So in that case, how do we actually write the condition? So if I wanted to write some condition, say for example, it contains class deal price, something like this, right? So I wanted to have only the items which are above some particular price, item price, say for example 100. So in that case, we can write it like this: text which actually retrieves the inner text, and it has to be greater than 100. So only deal price or the item price which are greater than 100 will be selected. So there can be multiple spans, right? Which will anyway, class will have the same name for all the items. So all the items are represented using the tag span, and which might have the same class name deal price text, right? So, but we wanted to select all the spans or all the items which have only the price greater than 100. So in that case, we can use it like this. So we can use text which actually retrieves the inner text, and you can write your condition here, right? So if you do text, it will identify, it will look at all the elements. But if we wanted to have a condition based elements we wanted to locate, so in that case we can specify the condition something like this. Here it is specified as items which are greater than 100, right? So only items which has the price greater than 100 or the inner text which is greater than 100 will be selected as the candidates, right? So this we need to know. Now let me show you one example. So let's say, for example, I wanted to identify using this current node div, this one, right? Div. Let's use ID or name, anything. So let me use name attribute here, name equal to Q. Say, for example, it's path. Okay. I just took it as ID. And then you can see when I do selection here, so this is highlighted and search store has been highlighted here. So this is the related XPath of this input field, right? One of one. Now, if I do / and do ancestor, right? So it has, let's say, for example, let's start with parent, then colon, and what is the parent of it? Form, right? So you can do form here. You can select form. See, when I say form has been selected because it's the parent of the current node. So what's the current node here? This input field, which has the ID as small search terms, right? So that's the current node slash parent. I wanted to select the parent. See, this is how I can select parent, colon is important, and then the tag of the parent form, right? So you can select it like that. No, I wanted to select the child of it. I will not get any suggestions, or you can't select any child here because this itself is a last node. It doesn't have any child. See, this small search items or this input tag doesn't have any children below it. So there are no matches. You can't select below that. Right? If you select ancestor, then you can select any of these divs. So you will have 4 matches because this input has four parents. Like div is the parent, again div is the parent of it, div is again the parent of the other div, like that. So it has 4 matches in it. You can see here. This input is coming from this div. Again, this div is part of header lower. 1, 2, right? Again, this will be part of another div. Yeah, this div, 3, and then 4. All are at the same level under the body. So 4 divs are there. This is the reason when you say ancestor div, so it is giving you uh, 4 matches. You have to specify it. Which div you wanted to select. First will be the first one from the current node. So above it will be the second one. When you do 2, it will be header lower. When you do 3, it will be the parent of header lower. If you do 4, it will be the parent of header itself, master wrapper page, right? That's how we need to identify it. So this we identified using DevTools, right? So the same thing can be done using the SelectorsHub also. SelectorsHub, it's very much easy. We have written this, right? You don't even need to write this. SelectorsHub itself will give you the ready to export of the current node, and from there you can actually write whatever access you want, right? For example, let me select the same part and then do SelectorsHub. I can just click on this and see here. Observe. When I select slash, so it will give you all the possible options. See, it has following sibling. So input has the following sibling. What is the following sibling? So we don't even need to look at it. Looking at this web page, you can clearly see the following sibling is button, right? It has button. You can use following, and then you can specify button. See, because we can clearly see input and button are the same level. So that's the first condition for the sibling. And we wanted to have the following, we wanted to have the element which is coming after the current node. Current node here is input, right? Input which has the ID as small search terms. So as it comes after it and it is at the same level, we use the following sibling. And we just specify the tag of it and it is selected. You can see one element matching here, right? Say for example, see when we do slash, so what are the possible options? So dot dot represents parent. So both parent and dot dot are the same. So if I do parent, right? So it will just say invalid export because you need to specify the parent of it. So I can just say form. So it will say 1 match because that's the immediate parent of it, right? See, it is giving what you wanted to select. You wanted to select parent is what it is saying. You don't even need to type the entire part, right? And child. See, when I say child, there are no suggestions from SelectorsHub because the current context node doesn't have any child. See, when you try to do it, it becomes red because there is no child to it. In order to identify the child, we can take some other element. Say, for example, I take this element. Let's cancel this header lower. Now I can select the child. See, header lower is my current node, and I'm trying to find all the childs of it, all the children of it. I'll just select div. So all the divs which are below this header layer node will be selected. So this will be one div. So these are the two divs under it, right? Header logo and some search box, store search box. These are two children of it. So in order to identify or locate the header logo, I'll be giving it as div of one. See, header logo will be selected now. Okay, it selects. Okay, both are at the same level, right? So we can't give it like that. So say for example, there are two element matches, right? So you can specify something like this. Even this is valid. Class equal to header logo. So it will identify header logo, right? In the same way, you can actually try accesses for others as well. See, when I do slash, all the possible accesses are suggested here. So what you wanted to select? Do you want to select the preceding sibling, parent, it has child, it has ancestor, descendants, and all, right? So you can even select the descendants as well. So descendants, colon, and then what the descendants are. It even has descendants as input, right? So you can do the input. Input is the one which we wanted to identify, input field, like this. Like this, you can play and you can play with this XPath axis and verify if they are actually correctly matching or not using the selector sub. And when you are doing this text function, right? When we are using text function, you have to be careful when we are using this text function. So, say for example, there is something called, I have seen something search store, right? So I wanted to show you something which has some text, right? So say for example, this register or login, which is login. Okay, login, right? So right click, copy XPath, or here it is the login. Yeah, here we have it. See, okay, let's take this. So this is actually representing that login link, right? So it is an anchor tag. It's a hyperlink, so it's represented with anchor tag A. All this is fine. So now let's get this here. So what is this normalized space is? So what we usually do is, in order to identify it, we can do something like this, right? So text, I can use text. I can do something like this, right? Text. So which actually gives me the inner text of this element A, right? So inner text of this element A. That's fine. Now if you observe, there is a blank space between log and in, right? So we have to provide it in single quotes. This is fine, but it will actually match. Say for example, it has some two spaces and also it has some space after login, right? Or if it has space before it starts the login. So in this case, text actually will not match. It has to be exact match. It has to be exact match. However, it is here, like, right? So inner text, it is an inner text. So it has to be as if like here when you are matching with the element. So when you do like this, if there is one extra space like that, then text function will not be able to identify the element correctly. It can't locate the element correctly on the web page. So that's about text. So, but we do have some other function to call normalize space. So when we do normalize space, then all the leading and trailing spaces can be trimmed. So say for example, if you provide something like this, still this will be valid and it will locate the element called login because it will trim the leading and trailing spaces. And also if you do have some spaces in the middle, all the spaces will be replaced with one blank space. One blank space, right? So you just need to remember this text actually expects the exact text which is present in the inner text, whereas normalized space, it ignores or it trims the trailing and leading spaces. And also if there are any spaces in the middle, it will just replace all these spaces with all these blank spaces with one blank space. So this you need to remember. Say for example, this is the one, right? So login is match. So that's about the uh, that's all about the XPath access and um, how you identify using XPath. So using one current context node, we can identify the XPath access of the. You can identify the elements of which has a relationship with the current node, right? And yeah, now another important interview question I wanted to discuss. So what's the difference between CSS selector and XPath? So in respect of time, like we do have some time today, so I'll just discuss some question here. Say for example, if you get this question, explain the difference between CSS selector and XPath. So what's the difference between CSS selector and XPath? Both can be used to locate the elements, right? So why do I go with XPath? I can use CSS selector itself, right? So the difference is CSS selector has some locators, fine. We can use it to locate the elements. But in some cases, right, there could be duplicate elements with the CSS selector, which we can't actually resolve. But using XPath, we have multiple options to locate the element uniquely. So we use the XPath to locate the complex uh, web elements, right? So the web applications, the complex web application might have the web elements which are complex in hierarchy. So all those nodes can be identified. Why? For example, say for example, I do have some web elements, right? So I can use CSS selector and directly access the any element here, right? So say for example, I wanted to access this. It might have some attributes called ID, name. It can have some attribute. It can have some other attributes, right? So using these locators, we can easily identify using CSS selector. Fine. Say for example, this is not there, and also if you see, so this is top-down approach, right? So it is top-down approach. It will identify, it will search from top to bottom, and it will try to find this attributes of the element, right? And if it has any duplicates, so using CSS selector, it is a bit difficult to actually resolve the conflict. But when you take XPath, right? So using XPath, we can write top-down approach. We can come from bottom to top as well, right? So how do you come bottom to top? You can take some current node as a context. So say for example, this is our current node. So using this also, you can identify this element. So using Ancestor, we can identify it. So in this example, so we can even navigate through from bottom to top as well as top to bottom using XPath. But CSS selector, it is only top to bottom. So the selection or the navigation is only from top to bottom. Whereas XPath, you can even select it from top to bottom, bottom to top, right? So this is the main difference between XPath and CSS selector. You can commit, you can actually select it with different options, right? So we have different access. So using any of these access, using any of the context node, right? So any of the context node on the web page, we can identify the element which we wanted to identify uniquely, right? But CSS selector, it can only identify with the top-down approach. It can't actually, once using some other element in the below of the document, right? Web element which is at the maybe very below of the document, you can't identify the other elements, right? You can only use the limited defined locators which are within the CSS selector. That's the main difference. And yeah, definitely the performance for CSS selectors is will be higher. So it will be fast. So CSS selector will be faster than XPath because it has its own predefined locators. It can directly identify the element on the web page. Whereas XPath actually traverses through the nodes, right? So it actually has to, even though it is, if you write the relative XPath, it is still like an overhead. It has to go through the DOM and identify that element, right? Which you provided as a relative. So definitely the performance for the XPath will be bit more. Like, it takes more time to locate the elements using XPath when compared to CSS selector. But it's, it's all our requirement. So if we are able to locate the element easily or uniquely using CSS selector, then go with CSS selector. So if your web application is complex and web page has multiple web elements with more complex hierarchy, then prefer XPath to uniquely identify the elements. So that should be our answer. Is that clear? Any questions? All right. If you don't have any questions, then we can wrap up this session.